I want to start with the free body diagram, and I have to compliment you. We've turned a bit of a corner. I have not graded all of them, but I'm at least seeing that for the vast majority of you, you drew appropriate and complete free body diagrams. That's yay. So let's start with the free body diagram. There are 4 forces that you needed to identify. There's weight acting downwards. There's the supplied force or tension, whatever you want to call it, acting to the side. This is reducing the amount of normal force because we are pulling somewhat up on the box. But there still is some normal force because, let's face it, it says the box is moving at a constant velocity. It must be in contact with the ground. We must not be pulling up with so much force that we've lifted the box off the ground. That is something that you will have to consider. How hard would you have to pull to finally just lift the box off the ground, even if you're lifting it at an angle? There is a value that would work there. But with every bit that we pull, we reduce the normal force, right? Because the normal force is a responding force. Finally, there's friction. And friction is related to the normal force. So if we reduce the normal force, we're reducing the frictional force. All that look good to you guys? All right. We were told that there's a coefficient of friction of 0.3 and a mass of 50. So that means our weight, 500 if you'd like, or mg if you'd like. We know the angle on this one was 30 degrees. So let's take our picture and apply a coordinate system. And I'm hoping that we're reaching a point where some of this work that I'm doing is more theatrical than anything else. Some of you are beginning to realize that these steps are there to lead you to what you need to do, but largely you can probably start realizing you didn't really have to draw all of this just to be able to start breaking it up into components. I'm hoping that you are getting to those kinds of points. Some of you are, for sure. I'm going to make this the positive y direction and this the positive x direction. Really arbitrary because it's a net force equals 0 problem, correct? So we'll write that out too. Here's where a few of you ran into some trouble. I'm going to have a component this way and a component this way. I did see a few of you make the triangle on the top. That's a little weird. The angle was given on the bottom there. So just, I'd use the angle I gave you. This will be FA cosine 30, and this will be FA sine 30. All good? Saw a lot of this. This looks great. So here's where I started to, this is where I put together, are you able to put these pieces together? And that comes down to net force in the x direction equaling 0 and net force in the y direction equals 0. And I should have seen something like FA cosine theta minus friction equals 0. Generic right now, because if you had the other problem, you can just put your values in. The next one, though, a little more complicated. Normal plus FA sine theta minus mg equals 0. If I saw this, I was pretty happy. Can't solve it without that. That's what Newton's law gives you. This is not sufficient to solve the problem. If we look at just at what's given here, we're attempting to figure out this value. And we have these two values, and we have this angle, and that's it. You wouldn't be able to solve that if you didn't have more information. You needed more information. And the piece of information you needed is that friction is related to the coefficient and the normal force. You needed that piece, right? This allows you to take two things that are in opposite directions and bring them together. They're related through this relationship. I'm looking at a series of substitutions to make this work out. You guys see the same thing I'm looking at? A series of substitutions. There's a variety of ways you could do that. You could solve this for normal and this for friction and plug it into your friction equation, or you could do it in a set of steps. Like you could solve this one for normal force and plug this in for friction here. I don't care. You need, as a person who's doing the analysis, you need to get a single relationship that has got just the stuff you were given in it. So here's my solution. I'm going to solve this for the normal force. I'm going to substitute that into the friction equation. Do you see what I've done there? So solve this for normal, took all of this, put it there. I'm just trying to find a way to use the stuff I have. Now, some of you will find this easier to do if you just put numbers in and just keep going until all the variables disappear. I'm not going to do that on purpose because most of your exam is going to be you having to find an expression for your answer. So I'll put the numbers in last almost every time. That way we're doing both types of problems, both numerical problems and problems that are just symbolic. But we're at the end now. So we know that FA minus friction equals 0. So FA cosine theta minus friction equals 0. So that means FA cosine theta minus mu mg minus FA sine theta equals 0. That's all the substitutions. Every bit of it. We're not done, but at least we know theta, we know mg, and we know mu. This equation has one unknown in it. The analysis part's tough on its own. So I need to solve this for FA. Some of you can't do that. That was clear. You're okay up to this point, but you couldn't get FA isolated. So to isolate it, we need to get terms that have FA on the same side of the equation. So I'm going to have to distribute that mu, aren't I? There's nothing I can do until I break up that combination of things over there. So I noticed that students who got here sometimes couldn't get FA by itself. And many of you got right to this point, and then your algebra falls apart. So look, that's not me. That's practice. We're going to have to practice this. What I mean is I didn't teach you how to go from here. I assumed that you had this skill. But we might need to practice this a little bit, okay? You understand, though, almost all the credit on the exam is going to get you is about getting to this point. So this next part is labor intensive, but doesn't actually net you very many points when it comes to the exam. You understand why I'm saying that? You're probably going to get the majority of the points by getting your problems set up correctly and isolating the right values and recognizing what has to be eliminated. Your algebra is only going to be a point or two total across the whole exam. But here's how this algebra is done. Distribute the mu. Keep the terms with FA on the same side of the equation and move the terms without FA in them to the other side of the equation. This is a positive sign. When I distributed to mu, the negative times the negative makes it a positive. Factor out the FA. Now isolate FA. And now you put all your numbers in and you get an answer. Algebra, right? A lot of it. This is assuming you can get one equation. I guess we really should say that all of this was your algebra, correct? The physics was done when you got these two equations put together. That's where the physics ended. The rest of this was just algebra. But boy, there's a lot of it there. Now again, I'm giving you problems so far that are numerical because usually if you have numbers in there, these are a little bit easier to get to your answer because it's easier to figure out what you have and what you don't. But this is the kind of stuff that we're up against, okay? Giving yourself some information about what every step is about. This next one, all I did was put the stuff with FA on one side and put anything that wasn't with MA on the other. I'm sorry, it wasn't with FA on the other. Here, I factored out FA. I want to get it by itself. I'm trying to isolate it. And I think this step is the obvious one. That's where I got FA by itself. Now, you can do all of those things, and then when you plug it into your calculator, get it wrong. It happens. I won't say that Ellie did that. But that's all that happened. She typed something in her calculator wrong or something, because everything she did was perfect. She put the numbers in earlier. But you can still do all those things, and the number's wrong. That really is frustrating. But that's passing the exam. The number is the least interesting part of all of this. Who cares what the number is? The number is meaningless. None of you know what 147 newtons is, right? I could say that it's 45 Sheltons. It doesn't really matter, does it? Okay, so since this is another class, we're going to do this problem again. I'm going to slide that over there. And we'll start with a free body diagram, right? Almost everybody did a fantastic job here. I'm gonna stop belaboring this and doing all the all calls. There's clearly going to be a downward force due to gravity. I don't think we have to worry too much about going through our list. There's clearly a force that we must use. That's an applied force, angle of 50 degrees, something up there like that. I hope that you guys have gotten to a point now where you realize the normal force is a responding force. So when I go ahead and draw this normal force, I want to draw it in such a way that it's not as long as the weight, because I do know that the upward force I'm applying is reducing how much I have the box sitting on the floor, right? You get that part, right? So we're trying to make these as realistic as we can, or at least somewhat proportional. And that leaves us with one force left, which is going to be our frictional force. And our frictional force is a portion of the normal force. So I get a free body diagram that looks something like this. Any questions about that? Excellent. So with that being our starting point, the next thing we need to do is take the off-axis force. And I haven't drawn a set of axes up there, but there's a clearly implied axis that's going to work best for us, right? So assuming all of you believe this to be true too, I'm going to choose an axis that is horizontal for the x direction. And from there, break up my applied force into its components. So pretty straightforward, but let's get them in there anyways. A horizontal component and a vertical component. And the horizontal component will be FA cosine theta, where this is theta. And the vertical component will be FA sine theta. All good? Now, again, we're doing the any problem now, right? We're doing both problem A and B because I'm just putting symbols in there. So at the end of the day, you can throw your numbers in for your problem. This is a net force equals 0 question. I really hope that everybody had gotten that, but that was not the takeaway. I did have a few people put MA, but our system is not accelerating. I mean, it said in the problem, it's moving at a constant velocity. All good? So x direction, there are two. FA cosine theta minus friction equals 0. Questions? All right, excellent. Net force in the y direction also equals 0. We have 3. There's the normal force. There's a component of the applied force. And there's the weight. That's it. That's Newton's laws. That's what it gives you. So all that work is just to get here. Now, looking at this, there are several things that we can start right away. For example, I can do a substitution. I know that weight is equal to mg. Weight wasn't given to me, but I can make this substitution. I know that this is a good substitution to make because the mass of the box was given to me. So I want to work the mass into the problem. Weight wasn't given to me. But g is a constant, so I know that I can make that substitution. So I'll make that substitution. Now here's the thing. I don't know the normal force. I don't know the applied force. I don't know the frictional force. But I know everything else. But that's 3 unknowns and 2 equations. That's not going to be enough to solve the problem. I need a third equation. Well, there was a piece of information given in the problem that suggests what third equation we should use. We were told that the coefficient of kinetic friction was a value, 0.3 or 0.5, depending on which test question you had. So we need to find a way to utilize that. And maybe it will reduce our number of variables. So hopefully, and most of you brought this to the table, friction equals mu times the normal force. We're dealing with kinetic friction, so we're able to use this, the equality. Now again, there are 2 unknowns here, friction and normal, but I didn't introduce a new unknown. I still have 3 unknowns. That's 3 unknowns and 3 equations. So all I have to do is work out which of these things do I want to leave and which of these things do I want to eliminate. And I want this answer, the size of the applied force. And this is the analysis. This is where you as scientist and mathematician or engineer are trying to figure out how can I take the information that's given and work out to something I have. This is not Newton's laws any longer. This is algebra. So come up with a plan, a path. I have this function, and this function. And I'm trying to find a way to eliminate variables between them. Well, the top function I can kind of rewrite as an equality, right? You guys see that okay? If I do that, I could make a substitution that would eliminate friction. Do you see what I'm saying? Now look, some of you can't do this yet. So if you want my advice, every time I draw an arrow, draw on top of it, right on top of it, what we're doing, why we're doing it. If you want your notes to work for you, you don't have to decipher them. Make your arrow something big or do something different and say, I'm going to take these two things and substitute to eliminate friction. This is not the only way to do this problem. I'm giving you a method that I'm using. There's a lot of ways that you can go about getting what you need to be isolated. I'm just helping you with one. But that's what I'm going to do first. I'm going to say FA cosine theta equals mu times the normal force. I've created a new function that has eliminated friction. But there's still two unknowns in that relationship. Normal force and the applied force. But now I have two equations and two unknowns. So I can utilize that. I could substitute. I'm probably going to solve this one for normal force and then substitute it in for normal force in the other equation. So if I do that, normal force equals mg minus FA sine theta. By doing that, I can take all of this and substitute it in for the normal force. This now will produce one relationship with one unknown. Now, I'm hopeful that you can do those things, that you can see those things, but based on what I saw in the papers, no, that's not the takeaway. A lot of you could not do this. You got the three relationships, you had them sitting in front of you. You had these three things, but you didn't know what to do with them. Even still, when I put those two things together, I get FA cosine theta equals mu times mg minus FA sine theta. I am afraid there are people in the room who don't know what to do here, who can't get this to provide them with an answer. Now, if you've been plugging numbers in the whole time, it wouldn't look like this. And if you've been plugging numbers in the whole time, you probably have something closer to what you could probably solve because you're used to that. But we need to be capable people, and we need to come up with relationships. So I'm going to tease out the FA because that's what I want. I want the applied force. I need to find a way to isolate it. Well, I see that it's pretty buried on the one side. So there's a number of ways I can go about getting it to be unburied. But the way I'm going to choose to do it is to distribute the mu. I'm going to start there by breaking up that parentheses and get FA cosine theta equals mu mg minus mu FA sine theta. You guys who aren't very strong algebra students or not as proficient as I, you may want to write out, what did I do to go from here to here? That way you're not trying to figure out what I did. In the moment right now, you can say, I distributed the mu. And that way when you're going through your notes, you'll have that. Because those of you who use your notes know that sometimes it takes you an hour just to figure out what you wrote down. And this talking I'm doing right now is to give you the time to do that, to write the instruction. I need to get terms that have FA on the same side of the relationship. So I'm going to move the term with FA that's on the right side of the relationship to the left. All right? So I now have FA on the same side of the relationship. I'm gonna factor out the FA. So all I've done is factor out the FA. Assuming cosine theta plus mu sine theta isn't 0, and it's very unlikely to be 0. Do you see why it's very unlikely to be 0? It's two numbers. We're going to add them together. It'd be hard for that number to be 0. Cosine and sine aren't negative in the first quadrant, and it wouldn't make sense for that angle to be in the second quadrant, right? Or we'd be pulling in the other direction. So I don't think it's possible for that to be 0. I'm telling you this. This conversation isn't by accident. This conversation is different when this sign is negative. When this sign is negative, it's possible for this term to be a 0. And you would not be able to divide by it. The reason I bring it up is because if there's a negative sign there, that probably means something crucial happens when those two things are equal. Something important. So you have to watch for stuff like that because that's what the AP exam is really going to be about. If you want a 5 on the AP exam, it's looking for that kind of thing. That's where those points are going to come from. But this problem didn't have that. It was a positive sign. So I can divide both sides without worrying about dividing by 0. And that's it. That's the actual answer to the problem. It's actually the answer to every problem where an object is being pulled by a rope that has static friction. Right? There's no reason to do the problem again. It's been solved. You want your answer? Plug in your numbers. Yeah, some of you probably find this to be easier if you'd used numbers the whole time. And for some of you, that looks like a lot of algebra. I'll trust you will believe me when I say that is not, and we will have way more stuff in the future. This is just getting us started. We're just getting warmed up here. But this is what it takes to solve that problem, to really solve it. All right, that's what we had to do. If you want to become better, to become a more proficient algebra student, start taking time. Leave space. Look at your work. Be methodical. Those kinds of things, laying it out and being careful is important. If you want to be better, go ahead and look at this part here. Decide what it is you have and what it is you're looking for. Start working out, what can I do to start making the problem simpler? What substitutions are available to me? All right, are there any questions about this? So, and this being, say, theta, calculator mass m, and there's a coefficient of static friction between the calculator and the surface. And I don't remember exactly how I phrased the question, but it was something on the order of at what angle does it start to slide or something like that. Is that what we did? So do I have to do the whole thing over again? Or can I at least get us right down to where we had our net force equals portion? Is that okay? So we had net force in the x direction equals 0, and we chose that to be the x direction, right? So with that understanding, we had mg sine theta minus the static frictional force equal to 0, and net force in the y direction equals 0. So we had normal equals mg cosine theta. That's about where we left off, is that right? And what we talked about was the fact that the static frictional force is an inequality. So it's difficult to deal with inequalities in a manner that supports substitution, because if you saw what we just did a minute ago, we solved this for normal force, and we would have plugged that in here and then took this and plugged that in there. That doesn't work if there's an inequality. If there's an inequality, we can't use substitution because these two things aren't equal. In fact, it's saying that they're not equal. It's saying one is less than the other. So when you have an inequality, you kind of have to switch up how you do substitution. Yeah?
Yesterday you gave us theta was 50 degrees.
That'll be fine. I'll get there. I promise. I promise. I mean, I could replace theta with the 50, but I purposely want to leave it like that. Is that okay, Brianna?
Oh, I thought you were saying that you wanted to solve for the exam.
It's okay. I do.
No, it says the maximum.
I mean, or solve for theta, or I'm sorry, solve for mu. We had this problem yesterday, and you guys were leaving, and I was saying something about 50 degrees or whatever, and I don't care. That part doesn't matter. What matters is that when you were at the end of class yesterday and we were talking about what you're supposed to do next, I wanted you to come up with a relationship between the angle and the coefficient. And one of you came up to me and talked about it and said, well, I got an answer that was inconsistent with something you said in class. Yeah, it was. Largely, I was hoping that somebody would get the answer. And for those of you who didn't work it out, do you see what it is I'm about to do? Because the arrows there kind of indicate what we're going to do. Because we got this far in fifth period, so I think we can continue from here because it's right where we left off. So I'm going to make a substitution. Same kind of idea here. I want to see what is the relationship between the force down the ramp, friction, and the normal force. So when we were done, we created 3 formulas. Well, we created 2, and we brought in a third. But with a inequality, it's important that you realize I want you to preserve an inequality. I want you to develop a relationship that has an inequality in it if you're having to deal with an inequality. So we have a relationship that's going to have an inequality in it. I'm going to first take this function here, and I'm going to go ahead and make it an equivalence. That's pretty easy to do. Realizing now that this static frictional force is equal to mg sine theta, I can make that substitution over there. So I'll get mg sine theta is less than or equal to mu times, well, I'm going to replace the normal force with mg cosine theta. And now I notice that mg is on both sides of the relationship. Do you notice that too? Assuming it's not 0, and there's no reason to believe it is, I can cancel it out. And then I have sine theta is less than or equal to mu s cosine theta. What do we do next? Yeah? Yeah, perfect. So mu s is greater than or equal to tangent theta. Folks, if you know what mu s is, then you immediately know how steep you would have to make something for something to slide. Or better yet, what angle not to exceed so that something won't slide. Have you ever looked at the speed limits on like embankments when you're trying to make a turn? That speed is related to how fast you can go and still have friction hold you in place. They choose the angle based on the speed, but more importantly, they tend to choose the speed based on the angle. All right, guys.